In this video, I'd like to talk about choke valves. We use choke valves in order to regulate the speed at which liquid flows through the system. Flow rate is connected to speed and pressure is connected to forces within hydraulic systems, and so choke valves determine the speed at which hydraulic components operate. Choke valves are divided into two main groups, where we have valves that are dependent on differential pressure and valves that are not. Those that are DP dependent will witness a change in flow if there is a change in the system pressure, even if the setting on the valve remains unchanged. Let's assume that this is 10 litres per minute. What would happen then if the pressure in the system changes? Well, let's assume that a 100 bar differential pressure over a choke valve results in an oil flow of 10 litres per minute. If this pressure becomes 120 bar, the valve will deliver more than 10 litres per minute and the speed of the component will increase. So when the differential pressure over the valve changes, the volume flow and speed also change. On the other hand, you have valves that are not dependent on differential pressure. If this valve is adjusted to deliver 10 litres per minute with a differential pressure of 100 bar, the volume flow will not change if the system pressure changes. These valves are more advanced but produce a much more reliable speed adjustment because the pressure in the hydraulic system can change a lot depending upon which components are being used and what type of loads are being moved. This means that a choke valve that is not dependent on differential pressure is much more reliable. I will make a separate video about these types of valves as they are a bit more difficult to understand. They are called flow control valves. Put simply, this type of valve is a combination of an ordinary choke valve and a pressure reducing valve. We will cover this type of valve in another video. I will now explain how valves that are dependent on differential pressure work. These valves can again be divided into two subgroups. One group is viscosity dependent and the other is not. In this group here, you have valves that are dependent on differential pressure and viscosity. If the viscosity changes, usually as a result of temperature changes, the setting on the valve will be different. If you adjust the valve with cold oil, the adjustment will change when the temperature increases as the system runs. The viscosity of the oil will decrease and it will be easier for the pressure to force liquid through the nozzle, resulting in an increase in speed. Here you have valves that are differential dependent but not viscosity dependent. These valves are made in such a way that they obtain 100% turbulent flow through the nozzle and the viscosity of the oil will not matter. So, in this case, the adjustment of the valve will not change if the viscosity changes. For this reason, it is a better valve, as there is one variable less to consider. These are the symbols for choke valves that are dependent upon differential pressure. This is the simplest version. This valve is DP and viscosity dependent, and it is not adjustable. This could very well be a simple blend created in order to reduce flow and speed. These arrows on the hydraulic symbols indicate that the component behind the arrow is adjustable. This is the case for a lot of hydraulic symbols, such as adjustable pumps, motors, valves and such like. So this is a valve that is DP dependent and viscosity dependent, and it is also adjustable. I believe that this is the most common type of choke valve prevalent in hydraulic systems. When you see this angled symbol instead of a curve, it means that the valve is not dependent on viscosity, but it is still DP dependent. This valve here does not have an arrow, which means it is not adjustable. This valve is the same, but this one is adjustable. Here I have made a drawing of the simplest variant of a choke valve. A choke valve creates friction, which steals some of the energy from the liquid flow. This makes it harder for the pump to press liquid through the system, and the speed of the liquid is slowed down. You can see that there is a small gap between the valve body and the valve plunger with this valve adjustment. If you turn the valve wheel and adjust the plunger downwards, you will obtain an even narrower opening and the volume flow will be further reduced. If you adjust the plunger upwards, the opening will increase and it will be easier for the pump to press liquid through the valve, and the flow and speed of the component behind will increase. It is a very simple principle, similar to the way your kitchen faucet works. A faucet is a combination of an on-off valve and a choke valve. This is a more advanced type of choke valve. We call it a choke valve with an open return. It is used in instances when you want to control the liquid flow and component speed in one direction, but where max flow is required in the other direction. So if we have liquid entering on this side of the valve, the liquid will pressurize this valve seat and push it against the valve body. The higher the pressure, the harder the seat will be pressed against the valve body and the better the valve will be sealed. So if the liquid is coming from the left side and wants to exit the valve on the right side, the liquid is prevented from entering through the main port of the valve, forcing it to enter through these holes and to take another route through the valve. The liquid will then enter the valve on the other side of the valve seat. Therefore, in order to adjust the resistance, we can adjust this part of the valve and partly close these ports that the liquid is flowing through. The more we close these holes, the more resistance the valve will create and the liquid flow will be slowed down. This part of the valve can then be adjusted by the means of a thread. There are many different variants of this valve. This is just an example that is used to illustrate the principle of an open return choke valve. If the liquid flow is in the opposite direction, the pressure will work on the other side of the seat. The pressure will build up and create a force that is working against the force from the spring that keeps the valve closed. When the force derived from the increasing pressure is stronger than the force from the spring will compress and the valve will open, allowing full flow through the valve. So looking at the way the valve is drawn right now, you will have full flow from the right to left, but if the direction of the flow changes, the valve will close and force the liquid through the adjustable nozzles. This is the symbol of the open return choke valve. The choke valve itself is the same, but you can see a bypass with a non-return valve next to it. This is the working principle of choke valves. As I mentioned previously, they come in many different variants, but the physical principles are the same. A big thank you to all who speak warmly about this course. I really appreciate it.